All right, I'm listening. Go. I don't care. All right, let's take a quick look at 52. Just give me a second. All right, here we go. So on 52, I would like for you to put the equal sign, then make a fraction bar. Negative 12 divided by 2 is negative 6. Do you agree with that? And then I have t to the negative 3 and t to the negative 1. So my recommendation is just change it to t cubed and t like this. You agree? And then I have u5 and u to the first, so that would just be u to the fourth. And then x to the negative 4 has to go to the bottom. So it's x to the fifth and x to the fourth. That's my recommendation. All right. Then from there, I can simplify. So now I have negative 6t squared u to the fourth over x to the ninth. You agree with that?
Sometimes I feel like it's like 6.
Now, we're doing this problem right here. Let's do this problem. All right, and tell me what you don't understand. Tell me what you're not understanding, please. Well, I'm not on the, I'll be happy to go back to the first page, but kiddo, listen, it's much easier if we fix this. Like if you're happy with that, I can go to another problem for you. But if you're not happy with that, let's fix what you're not happy with here. Does that answer make sense? You sure? Now, what did you want me to look at? All right, Leah, what? All right, so with 54, please pay attention on 54. Does everybody agree? This right here is to the negative 1. So all that's got to go on the top. So I make a fraction bar. So m to the fourth n cubed. Now, if I put a to the first power, does that matter anymore? And then all of these go where? So that's going to be m squared n to the fifth. Anybody have any issues? Leah, is that good for you? All right, so how many m's up top? How many on the bottom? Which means there's what? 2 left on top. And what about the ends? 2 on the bottom. All right, Mr. Greep, what's the problem? Okay, good. So you understand that, Leah? Did that help? All right, what?
For that one, when you do the n3 minus n5, would it not be -2?
Listen to what I'm telling you. Look up there on the board. How many ends are on the bottom? How many are on the top? So if I cross them out, I will have 2 left at the bottom. You with me on that? If you said n to the negative 2, that's the same as 1 over n squared. We just don't want any negative exponents. All right, what? No. On this problem, 54. Does anybody have any other questions with 54? All right, Mr. Greep, what did you want?
Number 40.
Good for you. Let's look at 40. Now look, on 40, everything is to the negative 2. So everybody should have just put 3/5 squared, 9 over 25. Do you see that? Everything was to the negative 2. So we switched it, made it positive 2. All right, Mr. Williams, what? 56. All right, good for you, buddy. Here we go. Do you agree this whole thing is to the negative 3? So I got to move that whole thing. So I have 5a squared b to the fourth, and then 2a negative 2b cubed, and there would be a 1 on the top. Do you agree with that? Now I've got to cube them individually. So over here, 1, 5a squared b to the fourth. 2 cubed is 8. A negative 6. B cubed. Do we agree with that? Now, please watch. I'm drawing this right here, moving this up here. Because that has a negative exponent. Do we agree? And if I move it to the top, it becomes a what? Becomes a positive. So I make it a plus. All right, now does everybody see the 5 times 8? Does everybody see 5 times 8? 40. All right, how many A's on the top? How many on the bottom? That leaves me with, no, no. A to the what? A to the 4th. Right, 6 on top, 2 on the bottom. How many B's are on the bottom? 7. That's right, you're good. B to the 7th. How's that, Mr. Williams? Good for you now. Come on. I want you to keep this up all the rest of the 6 months or 5 months, whatever's left. Ask questions when you don't know.
Didn't you put stuff into the numbers in parentheses down?
Because it had a what? Because it had a negative exponent, right? Just, it has to move, right?
Why wouldn't you do it out and then move it down?
Because you'd have to tell me what 2 to the negative 3 is. It's a little harder to do 2 to the negative 3. Even though it's not, you could do it that way if you wanted to.
Then it would come on the bottom.
Right, right. I don't know what you're asking me. Hopefully I answered your question. Come on, Leah. I want to help you, girl. Tell me. You think you got it? That's why there's lots of practice. Come on, sunshine. What? All right, let's look at 44. Good for you. Okay, this is to a negative exponent. This is to a negative exponent. M cubed over K to the 1st, L to the 6th. Do you understand that?
Mhm.
Sure, that's your answer. If it has a negative exponent, moves. This has a negative exponent, so I drop it down below. This has a negative exponent, I drop it down below. This is a positive exponent, so it stays home. Sorry, what?
Sorry, there is nothing to repeat.
Go. Nothing? Anybody else?
Question.
Quickly. 58. Let's take a look at 58. Does everybody agree this whole thing is to the negative 1? So I have to do what? Flip it. So you just flip it right off the bat. C to the 5th, D, H, negative 4, 7, C, negative 3, D cubed. Do you see that? Now look, this H to the negative 4, I have to move that back. And then the negative 4 becomes a what? Positive 4. The C to the negative 3, do you see that, Leah? This comes up here. So now it becomes a what? Positive. Do we agree with that? Hello? So how many C's are on the top? 8. There's a 7 on the bottom, right? How many D's on the top? How many D's are on the top? 1. How many D's on the bottom? So that gives me how many? And then H to the 4th on the bottom. We agreeing with that? Anybody have an issue with that? All right, that's going to have to be it for that. Okay, write each expression in a radical form or write each radical in exponential form. So this is just basically information. All right, we're continuing our discussion with exponents. All right, so with your exponents, all right, in the past, we have talked about square root. For example, the square root of 9, we all know is what? 3. All right, so there are different ways of writing that radical symbol. All right, instead of saying the square root of 9 with the symbol, you can write it as 9 to the 1/2 power. All right, 9 to the 1/2 power. All right, not everyone has the square root. All right, now what I try to teach kids is I know 9 is 1 and the square root is a 2. All right. So that's why 1, the numerator is always the power, and the denominator is always the what? The root. Whether it's a square root, believe it or not, there's a cube root, a fourth root, a fifth root. All right. All of them are possible. All right. So now that you understand that, please look how simple it is. All right. I want to write 14 to the 1/2 as a root. So you would write that as the square root of 14. That's all you have to know. That's it. Anything to the 1/2 power is the square root. Now, look at number 2. Is 5 a square root? No. So this would be written as 5 square root, and then that would be x. Everybody with me on that? All right. Now number 3, that would be written as what? 17 square root y. Very good. All right. Now let's look at the odds. Number 5, how would I write that? (19a) square root of b. Everybody okay with that? Anybody? Yes.
Do not have both A and B.
Why do you say, why would you not? I don't know what that means. Why would you not?
Why is the A not with the B in there?
Does the a have the 1/2 power? Right? A doesn't have a 1/2. 19 doesn't have a 1/2. The only thing with a 1/2 is b. All right, now let's look at number 7. Now everything is under the square root, correct? So this time it would be parentheses, and then this would be 2n all to the 1/2 power. If it's under the radical, it has parentheses. All right, let's take a look at number 9. That would just be what? 37 to the 1/2. If you put parentheses around the 37, it wouldn't matter. All right, that's just basic information. That's something you just have to know. All right. Now, here, eventually, you'll get good at these numbers to where you'll be able to look at the 5th root of 1024 and just say that's 4. But most people don't know that, right? 4 to the 5th power is 1024. So this, I'm going to show you now how you can use your calculator. So if you have your handy dandy calculator ready, pull that out. All right. So here we go. All right. I need everybody to hit the math button. All right. Now, do you see how there's a cube root in there? Do you also see where there's an nth root? Hit that. Hit the nth, and then it comes up on your calculator. Let me find it for you. So under math, the nth root or the x root, I'm sorry, not n. So that's number 5, if I'm not mistaken. If you hit number 5, right? When you hit 5, now you can type it in. Put a little 5 in the corner, and then go in and put in 1024, and then enter. And what do you know? It was 4. Shh, shh, shh. Please make sure you understand how to use that on the calculator. Anybody having trouble with the calculator? All right, so let's jump to 13. All right. Now everybody do the 4th root of 2401. the fourth root of 2401? Anybody else get 7?
Yeah.
Or who doesn't have a calculator? Why don't you have your calculator? Come on, Greep. I don't care about it being at your house. Come over here and borrow a calculator. Here, come on. Bring your stuff with you. All right, here we go. Everybody's okay with that being 7. All right, check out 15. Now, for 15, type it in as 243, caret, and then just do 1 divided by 5. And hopefully that'll tell you it's what?
3.
3. Caret button is this,
The arrow up.
it's that right there. No. What? 243, then you hit this button. Caret is what they call that. And then 1 divided by 5. And it should come up to be 3. All right.
It's right above.
Look, guys, come on, seriously, you shouldn't ask somebody where the caret button is. There's a finite number of buttons on the calculator. All you got to look at is each button until you get that number, until you get that symbol. All right, come on, that's not that difficult. You don't want to ask somebody where a button is. Find it yourself. All right, now let's look at 17. Tell me what the fourth root of 6561 is. 9. And finally, that was the easy part. That was the easy part. All right. Now I've got the hard part. So here, listen, I need your help on the hard part. The solving the equations, that's the hard part. So I need everybody's looking up here. All right. In order to solve this, I want everybody to understand this has a base of 2 in it. I need someone to try to figure out 2 to what power is 128. Take your calculator out and guess until you get the right answer. 2 to what power is 128? Come on, it shouldn't take you that long. 2 to the what? 2 to the 7th. Everybody try 2 to the 7th and see if that's 128. Is that 128? All right, I'm not expecting you to know that. Eventually you will. So please look, I want everybody to write number 19 like this. 2 to the x equals 2 to the 7th. That's what I want everybody to write down. 2 to the x equals 2 to the 7th. Now, if the bases are the same, the exponents must be equal. The exponents must be equal. So in this case, the answer was x equals what? 7, because obviously 2 to the 7 now is 128. Is everybody with me on that? All right, we're going to do 20 together now. Everybody's looking at 20. I got to figure out 3 to what power is 81? 3 to what power is 81? Somebody tell me. 4. 3 to the 4th is 81. Thank you. And those of you guys who are waiting for the answer, tonight you're going to be not having people tell you the answer. So that's why I'm asking you. You got to keep trying until you get it. So now I want everybody to write down 3 to the 3x plus 1 equals 3 to the 4th power. Everybody with me on that? Now, are the bases equal now? Because the bases are equal, what must be true about the exponents? They have to be equal. Thank you for saying that. So 3x plus 1 has to equal what? 4. Subtract 1. 3x equals 3, so x must have been what? 1. The bases have to be equal. So your objective is to set the base equal, and then you set the powers equal. And then that's how you solve these. All right, so let's look at 21. Ooh. Can 4 to what power? So everybody do 4 to the first, 4 to the second, 4 to the third, 4 to the fourth. Does any of that work? No. All right. So this one's a little bit harder. All right, I'm not going to put this on the test, but if you want, you could say this one's a little bit harder. All right, the reason why it's a little bit harder, and I'm going to point the ones that are hard to you, and I'll fix it so it's not hard. You have to convert them to the same. Well, hold on a second, guys. Let's just cross out 21. All right, this one's just too complicated. All right, that's too complicated. All right, so let's go over to 22 now. I got to figure out 5 to what power is 15,625. Somebody come up and tell me what that answer is. Somebody said 6. All right. Therefore, x has to equal what? X has to equal 6. Yes. They're just trying it. They do 5 to the first, 5 to the second, 5 to the third, 5 to the fifth. Eventually, they'll type in 5 to the sixth. It's annoying at first, but eventually, if you do it enough, that's how I know what all these answers are. Right? I've just done it enough that I know. You with me? But before you know, you have to just plug in the numbers and try. All right? That's how easy. It's nothing hard. All right? The calculator, that's why you have a calculator. Leah, what? I don't know what you mean. You're trying to figure out 3 to what power is 81?
But for like 22, you gotta plug in a bunch of numbers, you do the same.
Yeah, that's exactly right.
Well, on my calculator, what would I make since there's other things there?
I don't know. You mean the 3x plus 1? Look right here, girl. Look up on the board. You write 3 to the 3x plus 1 equals 3 to the fourth. Do you hear me? Yes? Look, come on. I'm not trying to be hard. Look, you see what I'm saying up there? Do you agree 81 is 3 to the fourth? Type in 3 to the fourth on your calculator. It's 81, right? So I changed 81 to 3 to the fourth.
You just like you don't have to write 3x plus 1 on your calculator?
No. That's what I'm telling you. No, do not do that. All right, that's the last part. You hear me? So now we're going to look at number 23 for me. Do that. First, tell me, Leah, 6 to what power is 216? You got to figure that out. I want Leah to tell me. Yes. So now you just write 6 to the 3x plus 2 equals 6 to the third. You with me? And now you write what? Because the bases are the same, the exponents must be equal. 3x plus 2. 3x plus 2 has to equal 3. You agree with that? Look, this, yeah, as soon as the bases are the same, you just set the exponents equal. You with me now, right? And so x was 1/3. Does everybody agree with x being 1/3? All right, so let's do 24 just to be sure. 16 is 4 to what power? That should be easy for you. 2. So everybody should write 4 to the 5x minus 3 equals 4 squared. So 5x minus 3 equals 2. So x is equal to what, guys? 1. All right, here we go. Help me out with 4096. 8 to what power is 4096? Do we agree? 4? So 8 to the x equals 8 to the fourth. Therefore, x equals what? 4. 9 to what power is 6561? Does anybody else get 4? So now we say 9 to the 3x plus 3 equals 9 to the fourth. 3x plus 3 equals 4, so x equals what? 1/3. All right. So on 27, 11 to what power is 1331? 3, right? So 11 to the x minus 1 equals 11 cubed. Here.
Thank you.
You're welcome. I need your homework. So x minus 1 equals 3. So x is equal to what? 4. Thank you. Okay. Because someone just came in, let's go ahead and help her with 28. All right. I need someone to come up and tell me what. All right. You need your calculator out. All right. We'll do a couple more examples. 3 to what power is 6561, please? How much? 8. And so x is equal to what? 8. All right. Now for number 29. So she's finally ready. Come on. I need you to tell me 2 to what power equals 512. And you just randomly guess it. Anybody agree with 9? Come on, type in 2 to the 9 on your calculator and see if it's 512. 2 caret 9. Do you know how to type the caret button in? You with me? So now you're supposed to write down 2 to the 5x plus 4 equals 2 to the 9th. Now, because the bases are equal, immediately the exponents are equal. So 5x plus 4 equals 9. So x is obviously now what? 1. Anybody have any questions with that? All right, let's try 30. 7 to what power is 343? Right now, I'm telling you guys, come on now. You got to be trying this on your own calculator. 7 to the x minus 2 equals 7 to what power? 3rd. And so now the bases are the same. X minus 2 equals 3. So x had to have been what? 5. All right, this one's annoying. 8 to what power is 262144? Anybody else say 6? So 8 to the x equals 8 to the 6th. So x equals 6. You with me? 5 to what power is 3125? 5 to the what? All righty. So 5x equals x, therefore x must have been what? 1. All right, 9 to what power is 6561? 9 to the 2x minus 6 equals 9 to the 4th. Therefore, 2x minus 6 equals 4. So obviously x was what? 5. All right, I think we have a pretty good understanding on that. All right. Now, everybody finish up while I just show Liv something real quick. All right, your job is to finish everything up. All right. You're welcome. 63, you're welcome. All right. So now look up here. All right. Something to the 1/2 power is equal to the square root of 14. See this? If it's to the 1/2, the 1/2 is the same as the radical square root. You hear me? So 3. You agree with that? All right, now go to your calculator now. I'm doing the 5th root. So math number 5. Then you type in 5 in that corner and 1024 and then hit equal and it should say 4.
It just takes a while.
All right. And then listen to the video if you're stuck.
I understand how to get like a 9 4.